Okay, so now towards the end of this chapter on the foundation of economics, I still want to spend a little bit of time working with some formulas and discuss again the difference between like the total of something and the first derivative, which is the marginal. So here we have a total utility function, for example, which is given by 16 times the square root of x. And this result, or this function, could be either be simply because of mathematical convenience, but it also could be the result of maybe some experiment or an empirical observation. But what is important for now is to discuss the shape of such a utility function. So if you take a look at it, u equals 16 times the square root of x. Well, if you plug in a value of 0, what is, so let's say if we have x equals 0, what is then the utility? Well, the square root of 0 is 0, 16 times 0 is 0. Well, if x is 1, and x could be like cookies, something that you consume. So let's say you have one cookie. How big is your utility? So then we substitute 1 for x, 16 times the square root of 1, that is 16. Well, let's just move on and let's discuss what happens if we have, let's say, 4 cookies. So if we have 4 cookies, what is the utility? 16 times the square root of 4. Square root of 4 is 2, so we get 32. And maybe let's do one more and skip 5, 6, 7, 8, because it's difficult to take the square root, but it's easy to take the square root of 9. And I didn't want to do a... By the way, you can see I've activated the keystroke, which will be useful later when I show you the same thing in Excel. So 9. So if you substitute 9, then square root of 9, that's 3. 3 times 16, that's 48. Okay, so now what does this formula, what does this equation look like? Maybe let's draw it here. Okay, so here if we have x, and here we have the total utility. Okay, so let's say we go here, this is 10, then maybe this here is, let's say this is actually 9. So this is, let's say, 9, then maybe this is here 4.5, so maybe this is 4, then this is 2, and maybe here this is 1. And of course this is 0. So at the value of 0, this is 0, and here we have, let's say, the maximum is 48. Let's put that here. Okay, so if x is 9, we have here a value of 48. And if we have a value of 4, we have 32, so maybe here 48, maybe half of it. What is that? That's 24. Then, not 29, 24. Then maybe 32 is somewhere in between here, so maybe, I don't know, maybe here's 32. Then at the value of 1, we get a 16, so maybe that's somewhere here. So what you can see is that we get a curve which has obviously this curvature to it. And this curvature, the technical term for this specific kind of curvature is called concave, because I think, if you look from here into that curve, so let's say this is an eye, and you look into it here, it looks like looking into a cave maybe. So that's supposed to be an eye. So when you look from the x-axis into a curve, does it feel like you look into a cave? Then it is like concave. It could be different, then it's called convex. But this is what we call concave. But it's not so important for now. What's important is the curvature. So now what you can see is that initially the slope is very steep, and the more we consume, the slope is very flat. And that captures, or that represents, what we call the law of diminishing utility. The law of diminishing utility. What that captures is simply the fact the more you consume, yeah, it's good to have another cookie, but the second cookie, the extra utility that you get from the second utility is not as great as the extra utility that you get from the first. And if you have a third cookie after the second, yeah, it's still good, but the extra utility that you get from moving from the second to the third is not as high as moving from no cookie to the first. So that is the idea of the incremental or the marginal utility. So now technically the slope of a curve, that is the marginal. So we can derive the marginal utility function. So the marginal utility is the first derivative of the total utility with respect to x. Okay, so what is that? So the total utility function we said is 16 times the square root of x, but that can also be written as 16 times x raised to the 1/2. So that's the same thing. So now if we take the first derivative, so if we write the marginal utility, then you know from your derivative rules that a constant is being kept. So this is a constant in front of the x, we keep that. But then what happens is we take the exponent that goes in front, okay, or in front of the x, so then we have here 1/2. Okay, so because it doesn't matter where you put it, so the 1/2, and then we have x raised to the 1/2, and then there is a second step, which is we still have to subtract here 1. So then we get here -1. So now we can write 16 times 1/2, that's 8. And then we still have x raised to the negative 1/2. And x raised to the negative 1/2, so this term here can also be written as 1 over the square root of x. So the result of the marginal utility is 8 over the square root of x. Okay, so how does that function, let's plug in some values for the marginal utility. Let's say if x is equal to 1, then what is the marginal utility? So we get 8 over the square root of 1, so that's 8 over 1, that's 8. Okay, what if x is, for example, 4? Then we get 8 over the square root of 4, so that's 8 over 2, so that's 4. And let's do again 9. If we have 8 over the square root of 9, that's 3, 8 over 3, that's 2.67. And what those values tell you is that at 1, this slope here at this point is actually 8. At the point of 4, this slope is 4. And at 9, the slope is 2.67. And it tells you if in this point you have a very slight increase of consumption. The extra increase in utility would be at the 0.9 roughly multiplied by 2.67. So if that were 1, so we go here plus 1, then we would go up here plus 2.67. Okay, so but the point is that the slope gets flatter and flatter and flatter, and that is captured by the fact that the marginal utility gets less and less. So we can use formulas in order to represent certain economic axioms like the law of diminishing utility very conveniently, and then we can work with those equations and build models and illustrate things that build upon of those standard assumptions. Okay, so if I drew the marginal utility, maybe here I draw the marginal utility. Again, I have here x, and here the marginal utility. So then those values, that will give us a formula that looks something like this. Okay, so let's do it in, that's just a pop-up message. Well, so let's just replicate that in Excel. So I pull up an Excel sheet, and the first thing we need to do is we need to define the x-axis. So I just say this is x, and let's just draw the curve from, let's say, 0 to 10, but let's have a step value of 0.1. So what I do is I enter 1, a 0. Okay, so now I want to create a column that goes from 0 to 10, but I want to have a step value of 0.1. So now I press Shift, add Control, arrow down, and you see this highlights the entire column. Then I go up again. And now I want to fill in a series, and you can do that by, you go to Home, and then there's something called Editing, and there is something called Fill Series, and then you have a step value of 0.1, and you want to stop the series at 10. And now what Excel did is it created a column that starts at 0 and ends at 10. Okay, so now let's add the total utility and the marginal utility. The total utility function was 16 times the square root of x. And of course the x I need to pull up from the first column. Okay, so now I need to copy down that formula. I can do that by double clicking on that little square. Okay, so now let's do the marginal utility. The marginal utility, we said, was 8 divided by the square root of x. Well, now we get something 8 divided by 0, so we will get an error, but that's not a big deal. And I still can copy it down. And I'll just blank that out, so then Excel thinks there is no value. And now let's see what those functions look like. I do it one by one. Let's do first x against the total utility. We go to Insert, Recommended Chart. Okay, so it's a little bit smaller. And let's So that is the total utility, and you see again this curvature, the law of diminishing marginal utility. Now let's do the same thing for the marginal utility, and let's draw that. So I highlight again the two relevant columns, insert recommended charts, and you see this is the marginal utility. Let's make it a little bit smaller so we can see both on the same screen. Okay, so that's good enough for. So you see that because this curve becomes flatter and flatter and flatter, the slope is becoming less and less and less. And we can interpret that as the marginal utility. Okay, I'll stop here, and then in the next video we do another function and discuss that one, but that will be a production function. But I'll just stop here now.